This lesson's on 7.1, Finding Square Roots. Let's go over some vocabulary. A square root of a number is a number that, when multiplied by itself, equals the given number. Every positive number has a positive and a negative square root. The symbol that is shown is called a radical sign. It is used to represent a square root. The number under the radical sign is called the radicand. And when you have the radicand is inside the square root right here. And we have also a root up here. And when we have a square root, it's normally not given to us or shown, but that is a power of 2. And that's going to help us to find two of the same numbers, as we mentioned in the definition for the square root. And the last thing we have to mention about is prime numbers. And prime numbers are natural numbers that are divisible by only 1 and the number itself. So for example, of prime numbers we have are 2, 3, 5, 7, 11, 13, and etc. Example 1, we're finding the square root of 144. So what we're going to do is we're going to do a division ladder where we're going to take the 144 and we put it right here. And then we're going to take a prime number. So we have to now start listing is all the prime numbers will be coming on this side right here. So what are the prime numbers? We'll go into 144. We can start with 2. 2 goes into 144. So 2 goes into 14 7 times, and 2 goes into 4 2 times evenly. Is 72 a prime number? It is not, so we have to do another round of division. So we can start with a 2. 2 goes into 7 3 times, and you may want to just do the math now on the side right here, but that gives us a 6, and 7 minus 6 gives us a 1, so we have this 12. So 2 goes into 12 6 times, and then is 36 a prime number? It is not. So we have to do another round of division. What is a prime number that goes into 36? We can use a 3. 3 goes into 36, 1 and 2. Is 12 a prime number? It is not a prime number, so we have to do another round of division. We can use a 3. 3 goes into 12 4 times. Is 4 a prime number? It is not a prime number, so we would have to find a prime number that goes into 4, starting with a 2. 2 goes into 4 2 times. And is that last 2 a prime number? It is. So this 2 right here, we can stop and we can start listing out are all the numbers that are inside the radicand. So we have, starting from this 2 right here, we have this 2 times another 2 right here, times 3 times 3 times 2. And then we also have to list this 2 right here. So 2. And as we mentioned before, the root number right here is a 2. So we're looking for 2 of the same number. So here's one group of 2. Here's a group of 3. And here's a group of 2. So inside we have a group of 2. We have a group of 3. And a group of 2. So when we take it on the outside, we have then is a multiplication of 2 times 3, that gives us 6, and 6 times 2 would give us 12. So our final answer will be 12. Now to check your work, if you put this back into the radicand, the 12, ask yourself, is 12 times 12 the same as 144? If it works, then you have the right number. If it doesn't work, that means your division ladder is incorrect. You would have to go back and try it again. Let's look at example 2, finding the square root. This time we have a fraction. So we're going to go ahead and split our fraction with, we're keeping the negative, but now it's going to be a square root of 9 as our numerator and square root of 100 as our denominator. So we're going to go ahead and do the division ladder for 9. Prime number that would go into 9 is 3. 3 goes into 9 3 times. Now is this 3 a prime number? It is. So that's going to give us the 3 inside our radicand. So that's 3 and 3. And now we have to work on the 100. So 100, a prime number that would go into 100. We can actually start with a 5. And so 5 goes into 100 20 times. Is 20 a prime number? It is not, so we have to try another prime number that would go into 20 evenly. We could do another round of 5. 5 goes into 20 4 times. Is 4 a prime number? It is not, so we're going to go ahead and use a prime number of 2. 2 goes into 4 2 times. Is that 2 a prime number? It is. So we're going to go ahead and list that in there. So we have is 5 times 5 times 2 times 2. And we're looking for a group of 2s. So here's one group of 3. So that's on the outside of our square root. Here's another group inside here and here. So 5 times 2 gives us 10. So our final answer is -3/10. Example 3, we're going to go ahead and evaluate this. Now let's use order of operations anytime you have to evaluate. So I'm going to go ahead and write our order of operations. Okay, do we have a parentheses? Yes, we do. We have a parentheses and we have a square root of 9 inside the parentheses. So let's go ahead and do our division ladder for 9. What is a prime number that goes into 9? A 3. 3 goes into 9 3 times. Now is that 3 a prime number? Yes, it is. So we're going to go ahead and leave it as the square root of 3 times 3 squared plus 5. Inside the square root of 3 times 3, there's a group right there, which I can take out, and that becomes just a 3 on the outside, squared plus 5. And then now we have is an exponent next. So exponent, 3 squared will give us 9, because that is 3 times 3. And we copy our plus 5. Do I have a multiplication? I do not. Do I have a division? I do not. Do we have an addition? Yes, we do. So 9 plus 5 gives us 14. So our final answer is 14. In example 4, same thing. We are going to go ahead and evaluate. So let's go ahead and write down our order of operations. So do we have a parentheses? We sort of do have a parentheses with the square root here. So I'm just going to go ahead and put a parentheses around here because we're going to work on that one. And as we have done before, we're going to separate our square root of 1 divided by 16. So we have a square root of 1 as a numerator and square root of 16 on the denominator. The 1 will always be a 1, so we don't have to worry about that. But the 16, let's go ahead and do our division ladder for that. So a prime number that goes into 16, we can start with a 2. 2 goes into 16 8 times. And is 8 a prime number? It is not. So let's go ahead and do another round. What would go into 8? 2. 2 goes into 8 4 times. And is 4 a prime number? It is not. So we're going to do another round of 2. 2 goes into 4 2 times. Is 2 a prime number? It is. So right here we can stop because that is a prime number. So inside the square root of 16, let's go ahead and take out the top part of the square root of 1, which will give us 1. And inside the square root of 16, I'm going to go ahead and list out all my prime numbers. I have is 2 times 2 times 2 times 2. And we're looking for a group of 2 of the same numbers. So here's one group. And here's the second group right there. So we take that out. It's going to be 2 times 2, giving us 4. So outside of that square root is going to be 4. So let's rewrite that problem as 10 minus 4 and it's 1 over 4 right there. Okay, so now do we have an exponent? We do not. Do we have a multiplication? We do. We have is that 4 times 1 over 4, which then will give us basically 4 over 4, and that 4 over 4 equals a 1, so we have as 10 minus 1. We go to the next order of operation. So do we have a division? We do not. Do we have an addition? We do not. Do we have a subtraction? We do. So we have 10 minus 1, which equals 9. And so answer is 9.